Hello, everyone. Our objective today is to understand the importance of hydroelectric energy in the world. So the main learning objectives is to understand the basic of hydropower and its importance. Very brief history. We'll go over the different types of hydroelectric energy, the advantages and disadvantages, and also a brief overview of the hydroelectric energy. What is hydropower or hydroelectric power? Hydro means water. So it is a form of renewable energy that uses water that is stored in a dam, or it can also be a flowing river that is used to create electricity that will be put in the electric grid. So this facility is called as a hydropower plant. Its significance is that it is very clean, reliable, it's domestic, versatile, and it is a reliable source of energy. And it is going to play a huge role as we transition from fossil fuels to clean energy fuels in the future to combat climate crisis. Let's look at hydropower in the United States. In USA, it is the second largest. Wind energy used to be the first 4 years ago. 38% of the renewable energy source came from hydropower, but wind energy has recently taken over. So it produced about 38% of the total renewable energy electricity and 6% of the total US electricity. The top hydropower states are Washington, California, and Oregon here. So everywhere you see those blue bubbles is where hydropower is being made. In the world scene, all the countries that are shown in dark green are big producers of hydropower. And you can see again, it is China, which remains the world leader for the installed capacity, followed by Brazil, USA, Canada, and India. You can see in this pie chart here. A brief history about hydropower. See, water power has been used for thousands of years. See, the Greeks used it for grinding wheat into flour. 1700s, it was again used for milling lumber and for pumping irrigation water. In 1878, the world's first hydroelectric power, this instrument was developed and discovered by William Armstrong in London, in England. In USA, Appleton, Wisconsin became the first operational hydroelectric generation, producing 12.5 kilowatts that can feed up to 250 lights. So the hydropower, we call it as very renewable and sustainable and clean because it is dependent on the water cycle, which is natural. And the water cycle goes on and on. And it is, here in this depiction, you can see how the sun propels the water cycle. So there's water evaporation from all the water bodies like lakes and rivers and oceans. And there's also transpiration, which is water loss from plants. They condense under around some particles in the atmosphere. And when conditions are right, they can come down as a rain, precipitation, which can be stored, and the energy in water can be used to create electricity. So because the water cycle is very predictable and dependable, you can also say that the production of water is reliable, and it's also domestic. So the main significance of hydropower is that in 2020, a sixth of the world's electricity which is almost 4,500 tetrawatts of power, which is more than all the other renewable energy combined, and even more than a nuclear reactor. And here in the USA, it equals 7.3% of the total US energy generation. So this is very significant. So if you look at the world's generation of electricity by source, again, you can see the black region in the pie chart is coal, followed by natural gas, and here is hydropower, which is very, very commendable, 16% hydropower. It is the world's leading renewable source of energy. And it is capable of meeting the base load energy requirements. And this again shows China is leading the world. And here in China, there's this interesting dam, which is also the largest dam in the world, the Three Gorges Dam. So it's built over the Yangtze River, and here you can see it in the map. However, there was a lot of controversy with this dam when it was built, because it has, anytime you build a dam, you have to displace a lot of people. So this dam displaced over 1.2 million people. So several cities are like actually buried here under the water, drowned under the water. And there's also a lot of environmental problems that came into focus after this. It kind of like led to many sedimentation and landslides in the area, apart from disrupting the ecology, the fisheries of the region. But it's producing a lot of electricity, and it is serving like millions of people. And here's an aerial photograph of the dam when it was in construction, and you can see the magnitude of this project. So the world's largest dam. And let's look at the physics of hydroelectric power. So here's see, any water, like stored water in a dam, has potential energy. And when it drops from a height, mainly because of gravity, sometimes we pump also. When it drops, it is converted to kinetic energy. And when it pushes the blade in a turbine, it becomes mechanical energy. And then the generator converts it to electrical energy. Very simple. Overall, the physics is very simple. So let's see how a hydroelectric power plant works. So here is a reservoir. We call it a dam where water is stored. Sometimes it's kind of close to like a natural dam, and many a time it is man-made. So this is where the energy, the cost is. It's very expensive to build a dam. And it can disrupt the normal human population and the wildlife population. So when gravity is used to, when they open a gate, the water is going to move through a penstock, which is a tube that carries water to the turbines. So here, this is where it becomes kinetic energy. So the turbine blades are turned by the force of the water, and it is rotating the turbines. The shaft here that goes to the generator will make electricity. And then the electricity is led to the electric grid here. And then it goes to power homes. And here's some pictures, a repeat of the same thing I said in words. And this is what a turbine looks like. You can see the turbine blades that will turn the shaft, and then the rotor and stator of the generator to produce electricity. And this is what it looks like from the outside. They're massive. So this looks like a huge dam. So there are three types of hydroelectric power. It is classified based on installation capacity and the working head. When they say working head, they're talking about the height difference between the river flow and the outflow. So in a low head, the water head is below 30 meters. Medium head is 30 to 300 meters. And high head, see, high head is 300 meters or higher. So the thing is, larger the working head, larger the electricity generation. So when water falls from a height, it has more power, thereby generating more electricity. So you can see this is like very small size scale. Low head can be found in somebody's property. You know, where they have a little group, you can make your own electricity. And this would be a dam, which is high head. So let's look at the three types of hydroelectric power. The first one is called impoundment. It's a reservoir. So we here artificially they have created a reservoir. This is very useful when there is like a topology, like in this like hills and mountains across the flow of the river. So here, we are using a dam that is used in a reservoir, and they will open a gate, the control gate, and water will flow down the penstock to turn the blades in the turbine to make the electricity. But when you think of a dam, it also plays a huge role in flood control. And like this recreation, and then they sometimes, most times they have a fish ladder so that the fish can still migrate and not affect its migratory patterns. So this is called as an impoundment. And this is capable of producing tremendous amounts of electricity. The second one is diversion or run-of-river hydropower. So here we have a natural river. Because it's already flowing, there is a lot of kinetic energy here. So here we have a facility that will channel a portion of the river through a canal. You can compare it to like a penstock that will turn the blades in a turbine, thereby creating electricity. Sometimes the diversion is required. There are examples of where there's no diversion. So we are using the natural flow of a river water, and we've created a facility in order to harness the kinetic energy of water. It is projected this model is going to be the future, which is pump storage. So you can see like it goes hand in hand with wind energy and solar energy. And you can see the PSH facility, pump storage hydropower. It can store electricity generated by solar energy, wind energy, even nuclear energy. And that energy can be used to pump water from a lower elevation to a higher elevation. It's called as a lower reservoir to an upper reservoir. And depending on demand, they will open the penstock and have and generate more electricity. So when the demand is low, they just pump water to the higher location. And when demand is high, they will create electricity by opening the gates. And here's the different sizes of dam. There's these massive, large hydropower. Department of Energy defines large hydropower plants with a capacity of more than 30 megawatts. And there's these little backyard ones, that's enough to power like maybe a farm. So that's less than 100 kilowatts. No, this is small, like in a that can power a community. And the micro is the one that is you can find in farms and like a private one. Here's some statistics that shows the different dams that can be found in the USA. The Grand Coulee is a famous one, and the Hoover Dam that was built in 1936. It's a very popular dam, and it's talking about the capacity and also the type of reservoirs. And by now you know what a impoundment or a reservoir is, what pump storage is, and what run-of-the-river is. So here this graph depicts the different types of dams that you can find. And here's some the biggest ones that are also talking about location and the capacity. So you can see the Grand Coulee Dam in Columbia River in Washington, D.C. Not D.C., sorry, in Washington State is an impoundment type dam. And here's the capacity of the dam. So let's look at some of the advantages and disadvantages. First, it is very friendly to the environment. It's clean energy. It is emission-free. There's virtually no carbon dioxide, nitrous oxide, sulfur oxide, hydrocarbons, or any particulate pollution. It is renewable because it's following the water cycle. It's dependent on the water cycle. And one very important thing you have to note is its efficiency to create electricity is very, very high, 80 to 90% sometimes. And it is dispatchable with scalable storage capacity. It has low operating cost and it has a long lifetime. So it is reliable, renewable, domestic. It's very environmental friendly. Some of the negatives, as most renewable energies, is the initial cost. Like building a dam can go up to millions of dollars. And habitat loss, especially the fishes, the wildlife, because it's going to occupy a lot of space. And, people have to be displaced also. Social impacts of displacing indigenous people. And it can be dependent on the amount of rainfall and snowfall. It affects the ecosystem because it affects the oxygen content in the water and also the temperature of the water, which can affect fish populations. The fish ladder is vital for fish migration. So any design should take into account that. And it's very expensive. Again, more research and development is required for the future, in the future for hydroelectric power. So in the future, the focus should be in technology advancement, where we are developing innovative technologies, sustainable development and operation, where we would take into control the effect on the environment, social and economic factors. It is projected that the new pumped storage hydropower, PSH technology, it will further be used, where we will it's like a collaboration of wind and solar energy and even nuclear energy. So they all work together to provide clean, reliable energy that can be put in the grid. And I hope that was